Kalma. Kalma. Upo ka muna. Upo. Guys! Hinayag daw ni Mami. Punta daw tayo sa sa may rest house namin. Malayo ba yun? Hindi naman. 7 hours lang.
Kailan?
Gusto niyo bukas na? Mga 3 PM, ganun. Call ba kayo?
Game?
Sige!
Sino may kotse?
Meron sa baba. Walang driver.
Kung ako na kayo ang driver nyo.
Ayun, ayos na pala eh. So bukas na? Tara na. Mag-prepare na tayo. Tara, uwi na tayo. Bye-bye. Bukas na. Exciting yun, no? Oo nga eh. Gamit mo.
Annamor!
Hi guys. So, pasok kayo.
Maka-exciting na natin na.
Exciting to. Lagay mo bag niyo.
Okay.
Diyan na lang.
Dami pagkain ah.
Wala. Louie, dito ka daan. Hindi, dito tayo. Kaya makapain.
Saan ba?
Dito pa sa harap.
Okay, game na ba lahat?
Game na!
Where are we going?
Anna's cabin!
Where are we going?
Anna's cabin!
Where are we going?
Anna's cabin!
Oh, namatay yung ilaw. Louie, tingnan mo yung nasa daan. Asan? Louie! Louie! Taga Louie!
Louie.
Teka lang, nasaan po ako?
Basta nasa ibang lugar ka ngayon.
Yung po mga kaibigan ko, saan?
Ligtas naman yung mga kaibigan mo. Pinapunta ko sila sa ibang lugar, pero kinuha kita dahil may mission akong sabihin para sa iyo.
Ano po yun?
Sumama ka sa akin. Sa case nyo kanina, tinatawag na banking of curves yung problema nyo. Isa siya topic sa physics, pero may paggamit din dito ng trigonometric identities. Kaya ang physics sa trigo ay konektado lang.
Hanggang dyan po ba kailangan yun?
Oo. Gusto mo simulan na natin?
Sige po.
Banking of curves. Ang banking of curves ay may tatlong concepts. Ito yung lever surface, bulk turn, at centripetal force. Sa lever surface, vertical force lang or direction yung nag-a-act sa isang sasakyan. Sa bulk turn, may horizontal at vertical direction. Ganon din sa centripetal force. Pero may nabuo lang na perpendicular at alam naman natin na pag nagkaroon ng perpendicular shape, magkakaroon ka ng two right triangles. Ano nga bang banking of curves? If the car is on a bank, the normal is not in longer vertical. So, a component of the normal force acts in the horizontal direction, and the component can act as the centripetal force on the car. Ano nga ba normal force? Normal force is a perpendicular to the road surface. There is a vertical direction of force acting on the car while on the surface, level on the ground lang. Ayun yung normal force. The car will have to move with just the right speed so that it needs a centripetal force equal to the available force. Ano bang centripetal force? Centripetal force is a force that makes a body follow a curved path. Pero, ang sasakyan ay hindi makaka-round ng isang curve kung ang centripetal force ay hindi equal sa available force or ang normal force. Given just the right speed, a car could safely negotiate a bank curve even if the road is covered with perfectly smoothly. Ang importance ng bumpers, hindi kailangan ng sasakyan na magdepende sa friction ng road or ng surface. Ngayon, alam na natin yung meaning at explanation of banking of curves. Na-explain ko naman yung mathematical concepts nito. This shows a free body diagram for a car on the bank curve. Horizontal and vertical position must be resolved. For vertical direction, there is no acceleration. So, pag walang acceleration ng isang bagay, gagamitin natin yung constant na acceleration due to gravity, or yung G. Ang constant nito is equals to 9.8 meter per second squared. For the vertical direction, the mathematical equation form is M for the normal force, cosine theta for the trigonometric identity, and for the angle of banking of curves is equals to the mass of the car multiplied to the acceleration due to gravity. Let's derive the formula in getting N, which is equals to mg over cosine theta, by simply dividing N by cosine theta, and simply dividing mg by cosine theta, and we can now cancel cosine theta, so we can get N, or the normal force. For the horizontal direction, it is stated that the net force or the normal force is equals to the centripetal force of the car, which is equal to the available force, which is also equal to the n sine theta, which is different from the vertical direction, which is the trigonometric identity is cosine theta. On the horizontal direction, the trigonometric identity used was sine theta. It is also stated that n sine theta is equals to mg cosine theta sine theta. If we will multiply sine theta to the quantity mg over cosine theta, we can determine a quotient identity from our trigonometric identities, which is sine theta over cosine theta, which is equals to tan theta, and which is multiplied to the mass of the car and the acceleration due to gravity. We can now solve for the horizontal direction and the vertical direction. Also, we are talking about centripetal force. The formula in getting the centripetal force is equals to the mass of the car multiplied to the velocity of the car squared over the radius of the curve. Di ba na-state dito sa horizontal direction na F net at ang centripetal force ay equal lang. So, we can derive the equation. mg tan theta for the normal force is equals to mv squared over r, which is equals to centripetal. We will find the velocity of the car in terms of v. So, we will derive the formula. Cross multiply r to the left side, then multiply both sides by m to cancel m on the right side. So, we will get v squared is equals to rg tan theta. But we want to na wala na yung squared. So, magkakaroon ng square root dito sa kabila. Kaya naging v is equals to square root of rg tan theta. Dito, makukuha na natin yung velocity ng car para successfully maka-round siya ng isang curve. A car moving with this velocity will successfully round the curve. Okay ba? Di ba kanina nga, yung in-explain ko sa'yo, sa backing of curves, yung car is dependent na sa friction. So, if dadaan yung car sa isang road, hindi na kailangan yung frictional force para makuha yung backing of curves at yung velocity. The given is R, the radius of the curve is 60 meters. The theta given, or the angle of backing curves, is 11.8 degrees. So, we will also include the acceleration due to gravity or the constant, 9.8 meter per second squared. What is asked in your real life situation is that what is the correct amount of velocity needed so that the car will not crash and it will run the curve successfully. Ngayon, ito na yung solution. For vertical direction, stated kanina na n cosine theta is equals to mg. So, in finding n, we will derive the formula n is equals to mg over cosine theta. For the horizontal direction, stated kanina na F net is equals to centripetal force is equals to n sine theta multiplied to the quantity mg over cosine theta multiplied to sine theta. We all know that centripetal force is equals to mv squared over r. And F net is equals to centripetal force. So mg tan theta is equals to mv squared over r. And in finding v, the formula is square root of rg tan theta. We will now use this formula in getting the answer on the word problem. Kung ganun, ang report pa na natin yung velocity, so we will use the formula v is equals to square root of rg tan theta. Ang gagawin lang natin is just substitute the given to the variables in the formula. For the radius, it is given that the radius of the backing of curves is 60 meters, multiplied to the acceleration due to gravity or the constant 9.8 meter per second squared, multiplied to tangent 11.8 degrees. So, let's multiply 60 meters to 9.8 meter per second squared. The result is 588 meters squared second squared over second squared. Multiplied to tangent, the angle of banging curves, which is 11.8 degrees. And we will get 114.29. Ngayon, alam na natin yung dapat na velocity ng car na papatakbuhin mo para hindi ka mabaga sa curve at ma-round ka sa isang successfully. Ano nga pala dapat ang velocity na kailangan ng car mo mamaya?
40 km per hour.
O ngayon, alam mo na.
Opo. Para saan pa po yan? Parang hindi ko po ata magagamit kasi patay na ako.
Sino mo sabi patay ka na? It is just your premonition. Pinakita ko lang sa'yo na mali dapat yung gagawin mo. And it is my mission na sabihin sa'yo kung ano yung tama na 40 km per hour ang dapat yung patakbo mamaya. Yan. So, alam mo na.
Opo.
So, pwede ka na makakabalik sa present time.
Opo. Maraming salamat po.
Sige.
Ngayon, alam ko na ang gagawin ko.